All right, if you have not tried these questions on your own, I suggest that you do. But if you're not sure what to do, of course, then just continue on with the video. Otherwise, put me on pause, try some questions, see how you do. Check out your work as you go by checking the video and seeing how you do. For the first example, it's already in its factored form. We know that the only way we can have the product of two things equaling 0 is if one of those two things is equal to 0. So either x minus 5 is equal to 0, which means x is equal to 5, or x plus 2 equals 0, which means x equals negative 2. So for either value, the equation will be true. It will end up equaling 0. For part B, if we try that again, we've got an x take away 7 equaling 0. And then that means x take away 7 equals 0, which means then that x equals 7. And for the other one, we have a 2x equals 0, or just x equals 0. 2x equals 0. Divide both sides by 2. And we get x equals 0 there. All right, for the third one, now this is where it gets a little bit trickier because when we were working with the parabolas, when we had y equals, if we wanted to find our x-intercepts here, it's not just a matter of switching our signs like it would be with the x plus 4. We know that x would equal negative 4 because x plus 4 equals 0. We know x equals negative 4. For the first one, the first factor, we have a 3x minus 1 would have to equal 0. So really, our 0 here is not going to be just equal to negative 1. And I'm having a little problem with my writing tonight. Let's try that one more time. Equals 0. To solve this, it's just like solving any other little linear equation. I would add 1 to both sides first, and I get 3x equals 1. And then we divide both sides by 3, and we get x equals 1/3. So those are the two values of x that would make this equation true, either negative 4 or positive 1/3. Now when you get down to the next three questions, these ones are not in their factored form. So we have to go through our factoring techniques that we had in our last unit and factor these first before we can actually find our solutions. So I'd be looking for two numbers that add to negative 1 and multiply to negative 12. So you can do that and factor them and go from there. If you want to put the video on pause, you can. And then I will put some solutions up. All right, for the first one, we found the two numbers were negative 4 and positive 3. So I put my equation in its factored form of x take away 4 multiplying an x plus 3. And then we set each little factor equal to 0 and solve. So I get my two solutions. Either my x is equal to 4 or my x equals negative 3. For part E, I was looking for two numbers that are adding to negative 7 and multiplying to 1 times 10, which is 10. And negative 2 and negative 5 do that. And because it's a simple trinomial, we go to our factors of x take away 2 times x take away 5. Set each factor equal to 0, and we end up with either x equaling 2 or x equaling 5. So again, if we were actually graphing y equals x squared minus 7x plus 10, we know that that parabola would have x-intercepts at 2 and at 5. So it's really like what we were doing before with finding our x-intercepts. For part F, I can common factor that one. I took an x out and it left me with an x take away 4, which means my factor of x is equal to 0, or x take away 4 equals 0, which means x equals 4. So again, two solutions for that, two x-intercepts there. Moving on to the next three, the last three examples. If we look at these, before we can factor, we've got to get everything to one side first in our equation. So I would leave my positive x squared here. I have my minus 4x, but instead of being equal to 21, I'm going to make that take away 21 equaling 0, and then we'll go ahead and factor that. The same for the next two examples after this. So give it a try if you have not done so already, and then I will put my solutions up. All right, if you've tried these questions, hopefully you found that negative 7 and positive 3 worked for our first for our example G here, they add to -4 and multiply to -21. And because we have a 1 in front of that x squared, we can go directly to the factored form here of x take away 7 multiplying x plus 3, giving us two answers, either x equals 7 or x equals -3. Again, like our parabolas, we're just switching our signs on our values that are attached to the x's to find our x-intercepts, or our zeros in this case, the solutions for our quadratic equations. Looking ahead to part H, this one I rewrote so that I put my x squared term first, then my x, and then I undid the -6 by adding 6 to both sides to get my new equation. And then I looked for two numbers that add to the 17, that middle term, and multiplied to the product of the outsides. So the 6 times 5 gave me the 30 here. And my two numbers that did that for me were 15 and 2. So this one, because it's not a simple trinomial, I went to that decomposition method and I broke that 17 down into the pieces of plus 15x and a plus 2x. And then I grouped for a common factor, and I got x plus 3 multiplying 5x plus 2, which then gives us two solutions, either x equals -3, or when I solve the second equation, little mini equation here, I got x equals -2/5. So those should be my solutions for part H. For part I undid the 18x on the right side of the equal sign by subtracting 18x from both sides. This common factors, I took a common 3x out. It left me with an x minus 6 as my other factor. And then when I set each factor equal to 0 and I solved, I got either x equals 0 or x equals 6 as my two solutions. Go ahead and try the assigned homework questions.